So today, basically, we'll be doing SQL. So actually, today we'll do a lot of things today, and I'll be going through a lot of slides, not this slides alone. So my other slide, I'll actually the you also be and we'll be doing a kind of real life case study today. So it will be much more practical and much more interactive today. So So these are the prerequisites. So there are different kind of SQL server that you can use. We have Postgres and we have normal SQL server and we have MySQL. So today, literally, I'll be using Postgres. Actually, you can use anyone actually, but today I'll be using Postgres. So the major difference between all is just some little syntax actually, not too much difference. So it's still the same, but just little difference. So So what does SQL stands for? It stands for Structured Query Language. So SQL lets you access and manipulate database. Basically, it makes you query database. As I said earlier, I think some classes ago, I said Python, you use your normal Python for your ETL, by extraction, transformation, and loading into database or data warehouse, actually. So what you now use to query the database is SQL. So that's basically what SQL means, actually. So what can SQL do? It retrieve data, insert, update, and delete, creates database objects, and so on. So basically, I will actually take you through some normal SQL commands, like the real meaning here. So that actually takes me to this slide. So so basically, basic SQL commands are data definition language, DDL. We have data manipulation language, DML, data control language, DCL, and transaction control language, TCL. So basically, the most important ones actually are DDL, data definition language, data manipulation language, and data querying. We have DQL, data query language also. So those are the important ones. So actually, you will actually understand better. So so learning objective actually is understand the importance of SQL in data engineering, differentiate between database, data warehouse, data lakes, and how they are utilized in real life scenarios. So, and understand querying types, DDL, DML, DCL, DQL, and TCL. So understand how SQL can be used to manage and manipulate data within organization. Yeah. So as I said earlier, SQL stands for Structured Query Language. It's a standardized language used to interact with relational databases. Think of it as a bridge between you and the vast ocean of data stored within. So let's move to database. So basically, a database is an organized collection of structured information or data typically stored electronically in a computer system. So database management software, DBMS, is an application that creates and access a database. So, and there are two major types of databases. We have relational database and non-relational database. So, and relational database, the data structure actually organize data in tables with rows and column. So just know relational database stores data in rows and columns, just like in tabular form. Yeah. And non-relational use different data models like document-oriented, key value, graph, wide column, store unstructured. Basically, just know non-relational stored unstructured data. So, and language used in relational database is SQL. So basically, you should just know relational database. What you actually use mainly is SQL to query the database. And various query language depends on the data model. So it depends on the type of data in the database. That's what you use to query. So that's it. So in terms of scalability, scale vertically, more computers power to a single server. Horizontal scaling is challenging and requires additional effort. So and scalability in non-relational is scale horizontally, add more server, share data between server, decreasing the request per seconds rate in each server. So performance, perform with intensive read write operation on small to medium data sets. So and in non-relational, high performance with distributed. So that's it. So you use case here, complex software solution, e-commerce, financial application, storing and scaling unstructured data. So basically, difference between relational database and non-relational databases. Relational database stores structured data in rows and column, like mainly data in tables that has rows and column. And non-relational stored unstructured data. So that's the major difference. So relational database relationship. So a relationship is the connection between the data stored in one table and another table. So basically, what the relationship is talking about is like the connection between different kind of tables. So today, in our real life, in our case study, you understand that better because we have different kind of tables. Because today we'll create a database. I will show you how to create a database, how you install, how you insert data into the database, and how you will query the database. These are all we'll do today. That's why I'm kind of fast today. So in all tables or datas available, there are always relationship in transactional datas or in business datas. So for example, we might have a business data or a business data. We will have a customer data. So different kind of datas actually. So there is always connection. So that's the relationship we are talking about. So, for example, maybe this is business data here, business table. This is customer. This is transaction. So there are always connection between. That's the major. That's what we meant by. That's what I'm saying. Talking about connection between tables actually. So relationship are created using keys. So relationship are created using keys. We have primary key and we have foreign keys. So basically, we'll go on now. I'll explain different kind of keys actually. So primary key is the unique identifier, like the ID, like you see written here. You have the ID. Yeah, that's the unique identifier. And foreign keys are the other keys. You understand? So they are the other keys, and they are the how will I put it? Like foreign keys are the other keys apart from the unique identifier, which is the primary key. So here, this is relational database keys. A key is an attribute, column, or set of attributes that uniquely identify a record in a table. Can you see that? Relationship are created using keys. Type of keys includes primary key, foreign key, surrogate key, composite keys, alternate keys, and super key. But the major keys that we actually need majorly are primary and foreign keys. Those are the two major important ones. So primary keys is a column that uniquely identifies a record in a table. Can you see that? It's a unique identifier. A table that can have only one primary key. The primary key column cannot be null. Can you see that? You can never have a null value as a primary key. It's a unique identifier of the table. That's a primary key. Foreign key is a column in a table that is a primary key in another table in the database. So foreign key is like, okay, let me take you back here. You have these are the IDs here. These are the primary key. Actually, when we move to the case study, you understand better. So the IDs here, those are the unique identifier. So here, this user here, for example, this user here, it's called, let's say, this user ID is a primary key in users table. So if it is in the ratings table, it will be a foreign key. You understand? So foreign keys are they are primary key in other tables, but they are present in but in when they are in other tables that they are not the primary key, there will be it will be a foreign key. So that's it. So we have surrogate key is key that is not generated from the data in the database. Rather, the DBMS generates a unique identifier. So actually, this type of key is not too important like that. But the major important ones are primary and secondary foreign key. So you can read it up when we give you this, so you understand better. So let me try to move faster. Okay. Relational database. The advantages of relational database. We have simplified model. It is user friendly, data accuracy, data integrity. So it is a simplified model. It's user friendly. It's easy to use, and data accuracy is top notch, and data integrity is perfect. So the disadvantages of relational database is maintenance challenges. To maintain it is very challenging. Cost implication, it might be expensive, and it is limited to scalability in the sense that when the complete is becoming scaled, there might be limitation to that. So, and structural complexity. So, and we have data warehouse. Okay. A data warehouse is a central repository storing data in querying form. Do you understand that? Is a data repository, central repository storing data in querying form. So basically, in when we are doing ETL, we store in a data warehouse. So they are stored in like they are cleaned. We have they are clean data. They've gone through transformation and they are just ready for querying. Those are the data stored in data warehouses. You can see ETL tools. So after ETL, the loading into data into warehouse. So that's it. So traditionally, data warehouse only contains structured data or data that can be arranged in table. Can you see? Just contains structured data and data that can be arranged in tables. However, modern data warehouses can also support unstructured data such as images. So those are modern warehouses can also support this. So they serve as an enterprise single source of truth. The data warehouse simplified the organization reporting and analysis, decision making, and metrics forecasting. So let's go to difference between database and data warehouse. Why these two data storage elements may be seen similar, they offer very different capabilities. Here is a brief breakdown of the differences. Okay. Database designed to record data. Data warehouse designed to analyze data. So can you see the difference? Database is basically designed to record data, while data warehouse is designed to analyze data. So if you want to analyze data, that's data warehouse for you. Okay, stores detailed data, stores summarized data, uses online transactional processing, OLTP, uses online analytical processing, OLAP. So these actually data warehouse mainly for online transaction processing, and these online the difference. Let me explain both for you. Online analytical processing are just um, um how will I put it? The database actually stores data for analytical purposes. Okay, you want to go through other analysis. Like, okay, you want to query, you want to build your Power BI from that, you want to analyze the data, you want to do your exploratory data analysis, that's data warehouse. So these just mainly for online transactional processing. Perform fundamental business operation and transactions. Allows users to analyze business data. So data warehouse is mainly for analysis. So those are the major differences. So data warehouse, data mart, and data lakes. Okay. Data warehouse is a multi-purpose enabler of operation and performs analytics. Basically, data mart is a subset of data warehouse built specifically for a particular business function, purpose, or community of user. So just know data mart. This can actually comes out in an interview. maybe in a job interview that okay, tell us the difference between data warehouse, data mart, and data lakes. So just know, basically data warehouse actually is used for to perform analysis, like is an online central repository for analytical purpose. Just know that's a data warehouse. So just know data mart is a subset of data warehouse built specifically for a particular business transaction, business function. So data mart is actually is a subset of data warehouse that is actually built for a particular function of or a particular business function. So that's a data mart that is just for only this business function. So that's a data um, mart for you. Function of data mart provide analytic capabilities for a restricted area of the data warehouse, offer isolated security and isolated performance. So it's just for single transaction actually. So we have data lake. So data lake is a storage repository that can store large amount of structured, unstructured, and semi-structured data in their raw native formats. So example of data lake is our S3 buckets, is our Azure blob storage. So that's data lake for us. It can store both structured and unstructured and semi-structured data. Okay, let's move on. SQL query categories. We have SQL queries are broadly categorized into five based on what they perform in the relational database. So example of Postgres that we are doing today that I'm using, we have MySQL. They are relational databases actually. So we have data definition language (DDL), create and define database schema. So it's create and define database schema. That's DDL, definition language. We have data manipulation language. You see the example. I will give you the as we go on. You see the examples of queries under data DDL, data definition language, data man. You see the example of queries. So I just want you to understand where each queries falls. So data definition language actually creates and define the database schema. Can you see that? Data manipulation language (DML) changes the database schema. So in case you want manipulation, you want to change, you want to insert maybe new thing or something, or you want to delete. And we have data control language, controls permission and access to data in the database. And we have data query language, retrieve data from the database. So if you want to retrieve data, you want to check data, you want to so that's data query language for you. And we have transaction control language, govern transaction and group tasks into a logical unit. So that's that. So let's move to data definition language. SQL data definition allows users to add, modify, and drop table, define and enforce integrity constraint, enforce security restriction, and create views. So example of DDL, data definition commands language, is create. Actually, we use the create to create database and to create tables actually in our database. Create is used to create the database or its objects like tables, index, function, views, and store procedures and trigger. That's create for you. We have alter, their commands. Alter is used to make changes to the structure of the database. We have truncate. Truncate is used to remove all records from a table. And drop is used to delete objects from the database. So those are the commands here. We have create, alter, truncate, and drop. We actually use that. So and these are their functions actually of each commands. These are the functions of each commands here. So let's this create. So here we use create to create table. For example, maybe you want to create a table. You want to create a student. We will actually do that. We want to create a student table, for example. So the ID, we create a table. We use create command. So the ID is an integer. Their name, there is a varchar variable character is more like text too. So and address, text, and email. varchar, which is variable character. So these are just data types actually. So as we move on, I'll tell you more on the data types. So alter is used to, maybe you want to change one or two things, or you want to add to the table. Alter table name. So maybe you want to add phone column to student table, for example. Maybe you want to ask, so you use the alter table to add the student column. That's the work of alter actually. And truncate. So maybe you want to change one thing or the other in the table. You actually truncate, or maybe you want to remove something. Truncate table students. So you want to truncate the table. And drop, you want to delete. So you want to delete the table. That's drop for you. So here, data manipulation language, DML, are commands used for adding, delete, and modifying data from table in a database. So here, the commands here, insert. You want to insert data into the table. You want to insert data into the table. You want to insert maybe a column, or so you want to insert more information. You want to put in more information into a table. That's when you use insert. Update. So you want to update data within a table. Maybe you want to update a specific data. Maybe there are one or two changes. So you want to update. So you use the update. Delete. You want to delete actually. Drop too can work for that, but you can use delete too for that. You have lock, table control concurrencies, and you have call. So which are not too important like that. The major ones are insert, update, and delete. So these just basic example of updates. From the student table, you want to update students, set address as, so you want to update, you want to put in more informations. That's when you use updates. So you want to put address. Maybe you don't have an address in the data before. You want to update it. So you use the update function. So delete. So you want to delete from the table. And we have data control language. DCL includes commands like grant and revoke, which mainly deals with rights, permission, and control of database. So that's that. So we have grant and revoke here, and we have data query language. This is very important. So we use it basically to query the database. So example of commands here, select. We use that very, very well. It's used to select, retrieve data from a table in the database. So that's select. We actually use select as times goes on. And we have data control language. Transaction group a set of tasks into a single execution unit. Each transaction begins with a specific task and ends well. All the tasks in the group are successfully completed. The transaction has only output like failure or success. So this mainly transaction control language, mainly for start a new transaction. But I think this is kind of advanced. So that's that. So let's go back to our normal slide. So you can see from here we have select. So from what we said earlier, select is what? Data query language. So like create, now you can see from here, you can see create. This is data manipulation language. These are all data manipulation language. This is data query language. So, so our case study for today is okay. It's for a company called Ravens e-commerce actually. So basically, the scenario here is an e-commerce company, Ravens, is facing challenge in efficiently managing its growing inventory of products, customer data, and increasing order volumes. The current system is fragmented and lacks the integration needed to ensure data consistency, streamline order processing, and enhance customer service. The inefficient results in increased operational costs, higher error rates, and is suboptimal customer experience. So that's the scenario actually. So the company basically they are facing the challenge of um, managing their inventories, their product customer data, their data inventories actually. So they need a kind of system that can actually help them streamline the whole process and helps them store data and make everything much more scalable. So yeah, this is the business problem here. The business problem is Ravens linked needs to implement a robust integrated order management system that consolidates product, customer, and order information into a single scalable relational database. So that's what they actually want. So they want to create a management system, which is a database that actually stores their informations. So the primary objective are to improve data accuracy. That's the primary. Just hold that. Primary objective. Streamline order processing, enhance the customer experience, and support future business growth. So that's the business problem here. So, and also they want to implement security measures to protect sensitive information and comply with data privacy regulations. Your efforts will be key to effective data use and driving business growth at Raven e-commerce. So that's that. So the objective here. So our objective here is database setup. Establish a Postgres SQL database named RavenDB to efficiently manage data related to sales, transaction, customer, product, inventory, and business operations. So data loading, we load the data. We are given the data. The company already give us the data. We actually load the data into our database. So develop SQL scripts to load and update data on the table. So data retrieve and analysis will do one or two analysis. Yes, create SQL scripts to retrieve and display the top three products of the by sales volume, enable initial data verification and analysis, and we'll actually do our matrix calculation. So our object, what we are actually doing here is we establish a Postgres database for the company, one, and we actually load the data into the database and we actually do some analysis like we query the database for the company. So there are different ways actually. You can always install Postgres in on your system. I already have mine here. So there should be you can actually do this on watching YouTube videos. Actually, there are YouTube videos that shows it's very straightforward actually on how to download Postgres actually. So I want everyone to have Postgres on their system. So you can always try this on your own because you just watching me without trying on your own, you might actually forget one or two things. But when you try on your own, you understand better. So this is Postgres. We have different kind. We have MySQL and we have SQL servers also. But I use Postgres. That's just I just use Postgres actually. I don't really have much. It's not that Postgres is better or one is better, but I use Postgres. The difference is just one or two things actually, or they're all the same. So yeah, let's create a database. So what you just do here is you right click. After right clicking, you create. You see different options when you right click. So you go to the create option and you see database here and you create you press it and you name your database. So our database name is Raven DB. Let's just name it Raven DB. So and you save that. You can see we created a database already. So in our database, so That's that. So here we can see this is a database here. These are database. So we have what is called schemas. And under schemas, we go to tables. This is where we have our tables. You understand? And let's see. Tables here, we have no tables here.
Database. What are all these things that come with it? They are very distracting. Do we need to
Yeah,
be
they
paying?
are very distracting. So what you actually need here is after creating a database, you see different kind of things here. What you just need here is just go to the schemas. The schemas. So after going to what we actually need here is table. This is where our tables will be. So let me okay. For example, now these are the data given to us by the company. We have this is ordered these are the ordered data. So let me see if I can see other data. Okay, we have products data too. This is for product. So you can see these are the datas we actually want to insert into the database. You understand? So what we actually need here is let me widen this. What we actually need here is the schemas. So we need tables. Everything here will be stored in the tables. So you'll see that now. So now from the table, we just from the table here, you right click the table and you go to query tools. So query tools is actually used. This is where you query your SQL. You understand? Query tools. When you right click the tables, you'll see query tools. So we go to the query tools. This is where all our query will be done. This is just like our notebook. You know, we use VS Code for Python. So this is just our notebook here on SQL. The first thing we did here is we create a database. So under the database, you have a whole lot of things. So what we just need here is the schema. You press the schema and you go to tables. In the tables, right click, you see query tools. Can you see that? So here in our query tool, let's create a table. So what we'll create the products table first because major thing you have to watch is when given a data, all the data you are given, you say, okay, this is a products table. It just have just one, from what we said. So you always know that this is the primary key here. So you check all other data given to you. Sorry. So let's check the order. Okay, the order here. Here we have a foreign ID here, a foreign key here. The customer ID is a primary key in the customer table. You understand? That's why it's the foreign key here because it creates relationship between the order table and the customer table. You understand? So when you want to create first, we actually build from the ones that just have just primary key but no foreign key. You understand? You create the tables that have the primary key first. That okay, these tables they don't have foreign keys there, and the product I think the product and customer don't actually have. So this is where we do our create. We use our create function. So let's do creates. So this should be in capital. So create table. Can you see? So let's create a table. Create table. What we are creating is product table. Oh, so create table product. this is how it's done. So yeah, okay, let's go to our product table. Where is okay? Let's check the product table again. So we have the product ID, which is the primary key. We have name, we have price, and we have categories. So we are creating that. So we have product ID. So we have serial. So that's the primary key there. We use product ID. That's the serial primary key. That's the primary key. So next, what do we have again? We have name. Name. So name here is what? Is a text. Can you see? So we put text. You understand? The data type. You understand? Not null. So we put not null because we don't want any we don't want any information, any data that has no value. We don't want it because when we don't include this, we might have problem in inserting informations because we don't want anything that doesn't have no value. It can affect relationship between our tables. So that's why I put not null. So what next? We have price. Price is what? The price is decimal, our normal data type. So we have decimal. So let's include not null also. So what else? We have category. That's categories. Oh, it's category. So that's text. Thank you. So we put not null because we don't want null value. So that's that. Here we won't put comma because that's the last. And after this, we will just put this. So that's that. So let's see if it will create this for us. So we highlight this, and to execute the script, we just press play here. You see a play, you see play here. You can see query returned successful. So let's see. So here we refresh. You can see it creates the table for us, products table. Can you see that? So that's that. Sorry, I don't know where. Okay. So let's create other tables too. So let's create other tables. So basically what I will just do here is seems I've done something like this before. Let me just copy and paste and I will explain each for us. So that's how to create table. So let me, because of our time, so I will explain each or what's all this for us. Don't know why this is actually running around. Okay. So this is our commands here. We already created the products table here. So after creating the products table, we'll create the customers table. So let's see our customers table here. So from the data provided, this is the customers. Okay. So the customer here, we have customers ID, which is what? The primary key. We have name and we have email. So yeah, we have create customers. Customer ID is our primary key. Name is text, not null from this. And we have email, text, but we use unique, not null. Unique means it has unique numbers here. You can see it's different, but they are text. Unique in this, it has all these ads. So that's why we use unique. You understand? So create so we create the order table. You can see here I use integer. You understand? So order ID is a serial primary key. Cost okay, let's go to order table so you understand that again. Where is the order table? Okay. You know, this is the order table. This is the primary key. This is a foreign key. You understand? So yeah, order table, we have the serial primary key here. The customer ID, you know, that's the foreign key, but we just put in the data type. You can see the customer ID. It's an integer. It doesn't have a decimal. And float is decimal. You understand. So it's still the same format. So you can see integer, not null, because we don't want a null value in our data. Because if you have a null value, a null class, it will actually affect. So we don't want. And we have order date is a date. The data type is date, not null. So at the end here, because we have a foreign key, we can't put the foreign key like, oh, customer ID foreign key. No, it should be kind of convincing. So that's why we put foreign key into comma customer ID because customer ID is a foreign key and it is a primary key here. So this actually creates interaction between the customer table and the orders table. So reference, we now put reference to customers in customer ID. Reference to customer table, you understand? We are referencing that primary key. So it's just like in normal English here. It's a foreign key. The customer ID here is a foreign key on the orders table. We now reference it to the customer table. You understand? We reference it to the customer's table. So to the customer ID in the customer's table. You understand? In which the customer ID in the customer's table is the primary key. So that's that. That's the customer's the orders table for us. And order items table. So let's open the other items. This is the data. So the other items has other item. That's that. So we have two foreign keys here. You can see is a primary key. The other ID is an integer. Let's go there. So you see whole number, that's integers. So we put not null, not null. Quantity is also integer, not null. So we have two foreign keys here. Order ID, reference to orders table, order ID. The product ID here, reference to the products table. So that's that. So let's create the table. So let's see. So you just highlight. If you want to, if you want to execute the query, you just highlight your queries and you press play. You execute scripts here. Oh, product already exists. So what I will just do here is the products table already exists. So what I will just do here is because I created that already. So let me delete. So that is the create table for us. That's data what's definition language. Create. So if I want to delete, I can use drop instead of deleting from here. That I showed you like, oh, I want to delete these. Like you understand? Instead of using deleting from here, deleting cascade because here deleting cascade means you want to delete all traces of that particular table. They are not just deleting. You just want to delete all traces of the that's delete cascade. That's what I will actually use here. So if I want to delete, there is a command or there is a query to use if I want to delete also. So let me try. Let me delete for you using this command. But actually, to make it much more easier, that's actually the best option. But for example, you want to delete, you can just drop table. So if exists, so what should we drop? Okay, let's drop other items. We can drop everything. Other items. Other items. So we put cascade. We don't want any traces. So cascade, we put this. So if I want to delete all the tables here, okay, let's delete all the tables. So let me just copy and paste instead of writing the command again. So I will just change the names. Yeah. So yeah, let's name this orders. This should be orders table. Okay, orders, and this should be customers. And this should be products. That should be products. So this command should have to be there. So let's see. Let's run the query. So tables are dropped. So let's refresh. You can see no tables. So let's take back our tables. We already have the queries here. So we execute here. So let's refresh. We have our tables back. Can you see? So now let's move to how we will insert our data into the database. You know, this company now, what they ask us to do is to create a database for them, so they will be able to store their database. So they can actually have stored data. So their data will be much more secured, and their transaction will be much more scalable. Now, if they have all their data together now, they can actually make a lot of analyses or subsequent transactional things, and they can always check their data easily. You understand? So that's the work of the database for the company. So now let's let's join our let's insert. So the customers table here. So what we actually do here is from the customers table we created here, just right click, you see import or export data. So we go to the import data, you see this. So from here, we actually file name. Okay, you see this page. So you just click on, actually, because I've done this before, that's why it's actually bringing this. So yours, you actually meet something empty. So this is the format here, because the format I have is a CSV file. In case I have any other format, for example, this is assuming I have any other format, text, binary, or anyone, you understand? I will choose. But here I have CSV. You understand? I have CSV here. So I click on CSV, and this is my file name. This will actually go to my computer files. I have them in downloads. So I need the customer's CSV. So I'll just click on that and I'll open. So it's here. So here, options here, I'll choose header. So that's it. Now, okay. So it's stored there. Can you see? So now let's check. The data is already in our customers table. So let's check. So this is where the data query language, select select star. Star means all. You understand? Select star from this data query language. Which table? From customers.
That's cool.
I think they should have this, yeah. So that's data query language. Let's can you see? Can you see the data there? So we query the database to give us all the customers table. Yeah, if we want from the specific customer, we select. Okay, let's select customer 5. We want to check for customer 5. Okay, let's say customer 12. Okay, there's an error, does not exist. Wow.
So
Let me Let me search that again.
Select staff and customers where customer ID is.
That is customer 12. Yeah. Yeah. So I just actually, yeah, I don't want to move to where yet. Yeah. So let's move to order. I just want it's little by little. So orders item. So import. So we'll go to the CSV file. Open. So insert that. Why? There's a problem. I don't want to see the problem here. Why is it failing? Okay. Let me try orders then. What? Okay. That works. So maybe there is a problem with our order ID. So let's try product. We import product. Open. Okay, this works too. So we need to check our order IDs table. We have order item ID. Okay. What's not the problem? Let me try this. Mhm. What can be the problem? Think something is wrong with our query, which I can't figure out now. Now it's created already. So oh, is this the wrong data? Those are the columns here. So I won't want this to waste our time. So let's still continue. I'll always find solution to this. Yeah, it went through now. Yeah, it went through now. So let's check. Select. Run. Order. I think. Okay. Yeah, this is it. Can you see? So that's a query language. So for example, let's do the insert. So data manipulation language. Can you remember the insert? So let's do inserts now. Like, okay, we want to update the database. We want to insert data. So basically, what we just do is let's insert into the products table. So okay, let's insert that way. Okay, just for us to know that we've inserted. So let's check our products table now. So how many columns do we have? We have 1,000. So let's insert. So you see our insert will work. Insert into, it's just a normal English product. So we have the products here. What do you have in our product? We have product ID underscore ID. We have name. We have price. We have category. So those are columns. So here the values will be, so we'll now put values to be in capital, sorry. Values. Okay, this means what are the values in those columns. So let's say we have 1001. That will be the product ID. That's 1001. So we have new, let's put new product, let's say new gadgets. Okay. New gadgets. Okay, is my spelling correct? And I have price. So let's say the price is 299.97, command category. That should be electronics. So that will be electronics. think that should be fine. Yeah. So we insert, okay, let's try our query. Column products. Oh, I made a mistake. Yeah. You can see there's a mistake here. Product ID. Yeah, I think that's a mistake. Yeah, successful. So let's check our products table now. Yard. No. We should add. Okay, already exists. So definitely it should be there. So okay, what I will do here is I will refresh. Yeah. So I will need to refresh the products. Yeah. So I think this should work now. Why? So can you see that? So let's try another okay, let's try updates. Okay, for example, let's update a customer email. Okay, let's check. Okay, which customer email can we update? Okay, let's check the customer table here. So we can check that. Let's just try another update. So let's select from, let's check our customers table. So that's our query language. I might not even put this. This should work. Let's try this. Yeah, it works. I might not put this here. So okay. So let's update, like for example, we want to update like okay, let's put okay. Okay, let's say we want to update a customer mail now, a customer email. For example, we asked to update a customer email. So we just say, okay, update customers So let's set email. We want to update the customer name as email as, let's say, Jane dot doe at gmail.com. So where, so this is what we use, where name is equal to so let's try this. We want to update the customer. With this work. Yeah. So we are updating this. So let's check customers. I think you should update the email. So basically, that's how to use the inserts. Okay, let's say is customer 2. Let's try this. Okay. So to update the mail. Yeah, that's a mistake I actually made. Actually, yeah. Customer 2. So where did he take customer 2 now? Yeah, you can see. Because so that's updating. Like, okay, you want to update, maybe the customer change the mail or the customer change the contact. You can always put that. You understand? To store the customer's new informations. Let's use another one now. Let's use customer ID. Let's say Muhammad. Where customer ID is equal to let's say where customer ID is let's say 499. So let's query this again. Use the cost. We can use any one actually. So let's go to our 499, for example. So you can see Mohammed Doe. You can see that. Here we use the customer ID in our where condition. But I want us to download Postgres, please. So we can all follow. So you can see, and these things here, this things is used to remove duplicates. You understand? Assuming you're having, because I don't think the data we are giving as duplicate, I would have just tried it there, but to give us the same results actually. So if I use distinct, you can see this distinct here. If I use distinct, that's just to remove duplicates. You can see SQL selects distinct is used to remove duplicates basically. But here in our data, I don't think we have duplicate value. So let's check. It will actually give us the same thing because I don't think we have duplicates. So if you know you having data that has duplicate, select. So it says what? So I don't think our data has duplicates. So and it won't work here actually because we don't have a duplicate, even if I try. So it's just like selecting one part of a column. So it will give us one result. Let's try it though. Distinct. Is my spelling right? Okay. Yeah. So let's say distinct name from customers. I don't think this will work here because we don't have duplicates. Just to select distinct values. Can you see? Just bring all the customers' names here. You can see. So that's distinct. And none have duplicate. Assuming we have duplicates now, it will remove duplicate values and return we don't have. So that's that. That's the distinct function. So which other function? So this is just like select this from where this just like can this actually works for us? Where age is greater than 20. So for here, we can just say select maybe price. Okay, select orders where maybe price. Where do we okay, where price is greater than 500, it will actually bring that out for us. So I think that shouldn't be. Maybe when you're trying yours yourself, you can always try that. So select name marks from students. Okay, where order by. So you order it. Okay, let's try something like this. Order by. So let's say let's try order by then. select which table. Okay, let's check let's try this table. Let me check what's in here. Okay, let's say select. No, don't let us use this. Okay, let's try the product. Because I think products will work for this well. Okay. Select price and category. So here we just want to check price and categories. Yeah. Category. So we can start from here, from which table? Products table. So order by let's order it by, what did I order this from? By let's order as by price. So this is descending. We can do ascending. This is in descending order. So let's try this. You can see. So that's that. That's order by. So we can always use and to join where dash is dash and. So we use okay, where okay, and. Star means all. Okay, let's use products. So select star from products. Okay, let me see how they use theirs. Where okay. So this is where our where comes from. So we can use small and we can use capital actually. Where and these actually work here. Okay. Okay. Where category. Yeah, let's use like that. Where category. Equals to, let's say, electronics. And price. Is greater than 200. Yeah. Is it the same? Okay. Can you see that? So it gives us just the electronics that the price is greater than 200. Can you see? So there are different queries here that we can always try. So here it says where not cities. That means we use where categories. So this one will just be where categories is not electronics. So it will give us all the categories that are not electronics. So that's that. So you can see our inserts that we just did. So this is the insert. So this one is when there is null value, where age is null. So in our data, we don't have null. So that this one actually, can you see? It's just basic. So this is update that we used to update our wherever. So delete. If you want to delete a particular data, you can always delete. So that's the delete function. So this SQL aggregate function. So next week, actually, we'll actually do aggregate function in our data. So I think using this our own data is better. So we can do the aggregate function and we'll do join before we actually move to the next. We do group by in our next class too. So it's just for us to do aggregate function on our data, the group by, and some other things too. So